Let's take a look at another special feature of a triangle, the altitude of a triangle. The altitude of a triangle is a perpendicular segment from a vertex to the line containing the opposite side. From a vertex to the line containing the opposite side. PY, line segment PY, is an altitude. Another altitude, from point S to the line containing the opposite side and perpendicular, line segment SX is an altitude. Line segment RZ is an altitude. What do we notice about these three altitudes? They intersect at point Q. Point Q has a special name. The point of intersection of the altitudes of a triangle is called the orthocenter of the triangle. Okay? And that's a word you need to remember. Where the three altitudes intersect, and here the altitudes are intersecting inside of the triangle. Sometimes they can intersect outside, sometimes they can intersect on the triangle. In our case, the three altitudes are intersecting inside, and that point is called the orthocenter. Let's take a look at an example where we have to find the orthocenter. We're given a triangle with these three vertices, and we're being asked to find the orthocenter. Recall, if we can find the three altitudes, where those three altitudes meet is the orthocenter. So that's our goal, our goal is to find three altitudes, or at least two altitudes, and see where they intersect. All right, first thing I want to do is plot my point, graph my points. I have point J, which is a -6, 0. Call that J. Point K, which is 12, 0. And point L, which is 0, 12. I have three vertices. I'm going to connect those to form my triangle. Looks like one of the sides of the triangle is the x-axis. That's pretty good. This one. Make sure we see it. Okay. I need to find three altitudes, or at least two altitudes. Recall, the altitude goes from the vertex. It's a perpendicular segment from a vertex to the opposite line containing the opposite side. In other words, I want to go from here perpendicular to the opposite side. That gives me my altitude. Well, it just so happens the y-axis is an altitude, is one of the altitudes of my triangle. Because remember, the y-axis is perpendicular to the x-axis. So that means I know one altitude. Let me go ahead, and I forgot to label this point. Oh, this is L. See it? Point L. So, one altitude is the y-axis, because it is perpendicular to the x-axis. Let's call this point M. Okay? So line segment LM is an altitude. That's one of my altitudes. I need to find another altitude. I need to find another one. Let's shade this in just a little thicker, because we have the y-axis, which is black. Okay, that's better. One altitude, let's find another altitude. Let's see. I need a line segment from this vertex perpendicular to this opposite side. Perpendicular. Well, you know, if I knew the slope of this line, then I could find the slope of the altitude that's perpendicular to it. Well, let's see. Do I know the slope of lines? Can I figure out the slope of line segment LK? Well, the slope of this line segment is rise over run. So I'm going to rise. I'm going to start at this point, which is 12, 0. I'm going to rise how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I'm going to run negative 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the slope of line segment LK is equal to 12 over a negative 12. The slope of this line segment is equal to negative 1. Well, what would be the slope of the line segment from J perpendicular? This is, try to remember which is which. This is line segment LK. That's the slope of line segment LK. So the slope for the altitude that's perpendicular to it, which I'm going to call, which would be the slope of the other segment, would be a positive 1. So I know the slope of this unknown altitude. I know a point. Can I find the equation of that line? And if I find the equation of that line, then I can actually graph that line. Well, let's see. Point slope formula. I know a point. I know a slope. Let's find the equation of that line. So it's y minus the point that I know is a negative 6, 0, because I know that altitude is going to go through this, going to have one of its endpoint at point J. So it's going to be y minus 0 is equal to the slope of this line is 1 times x minus 6. Oh, it's a negative 6. Okay, let's simplify that. We get y is equal to x, add the opposite, x plus 6. That's the equation of the second altitude that's perpendicular to this line segment LK. I know the equation right here of this first altitude. It's the what? It's the y-axis. So what's the equation of the y-axis? Is x equals 0. The equation of this line right here is x equals 0. What's the equation of my altitude? Well, I know a point and I know the slope. Okay? I can actually start at this point, and I also see, what's this? That's the y-intercept. So therefore, I know that this line is going to intersect the y-axis at 6. That gives me another point. So now I can connect those 2 points. And now I have my second altitude. Okay? The equation of this line is x is 0. The equation of this line is x plus 6. Using systems, I can now see that my 2 altitudes, where do they intersect? They intersect at 0, 6. And what is that? That's the orthocenter of the triangle. That's where the two altitudes intersect.